Hello, welcome to this 7th video in a development log or devlog where I'm making 3D snakes, or we are making 3D snakes. And in this video what I hope to do, let's just see the time, in less than 10 minutes, so kind of a coding challenge, speed coding challenge. Let's see if we can get these snakes to be a lot smaller. Right, just to introduce what's going on in this, I'm just going to turn my sound down because the stepping was probably very loud your end. Sorry about that. Right, so I've got 4 versions of the snake that we're working on. I can't remember what colour each one is. I think this is Mark 1, so the first version. Mark 2 might be that one. I know the white one is Mark 4, so the 4th iteration or version of the snake. So there must be one. Oh, there's another one. Maybe that's the Mark 1. Anyway, so there are 4 versions of the snake. But at the moment they are 1 by 1 by 1 in 3D space, and we want to be able to just play with that scale so that we get lots of tiny little snakes. For instance, over here we've got our egg object, which is kind of like a fountain that can spawn lots and lots of snakes. And I've made a button. If you're interested in how to make buttons like this that I can walk up to and it kind of goes green, and if I click the mouse it calls a function on another script. If you want to work out how to do that, I've made a video on how to do that, so you can find that. But there we go. So we want to be able to press this button to release lots of snakes, but we want them all to be small, so we can kind of make a community of tiny little snakes. So let's get going. So what we essentially want to do, if I select the 4th version of our snake, we want to have a variable up here which is called scale that affects the scale of our snake. Just to recall what's going on, the snakes that I've got in my scene to begin with are just coloured blocks, and there's 4, number 3 is green, version 2 is also green, it looks like. Where's 3? That one's green. Snake 2 is also green, and where is the first snake? Oh, snake 1 is like the plain white. So they start off with a 1 by 1 block, and then the script, and I've got 4 different scripts here for the 4 different versions. I called version 3, or started saying in videos, Mac instead of Mark. I apologise for that. Mac has something to do with the speed of sound, hasn't it? Something like that. If you're going Mach 5, is that like 5 times the speed of sound? Something like that. Anyway, I meant to say Mark. Mark is just the version Mark. Okay, so I've got 4 different scripts for 4 different snakes. We're going to work on the 4th one, so Mark 4. And as I was saying, when the scene starts, so in the start function, what will happen is each snake will go and grow its tail. So however many segments I've asked for, don't know if this script is large enough, let's make it a bit bigger for you, then it goes and grows that many segments in this function growTail. So basically what we want to do, when we've made each segment, which I'm doing here, I'm saying gameObject S equals a new primitive, a new cube. Once we've created that cube, we change its position so we could change its scale. So we want to be able to say something like, now you can't change each component X, Y, and Z of the scale individually. You have to create a new vector. So that's like a variable that holds 3 numbers, and then replace it whole scale. So we have to say something like S transform dot, now you've got 2 scales, lossy scale and local. Local is the only one that you can go and, I don't know if I can show you this, you can go and set, you can get what the local scales are, X, Y, and Z, but you can also set them. Lossy scale, I think you can only get it, so you don't have access to go and change things. So we definitely want local scale, and then we want to say equals something like new scale. That's what we want to say. A new scale will have to be like a temporary vector 3 object, which we're going to make up here before we go into the for loop, which creates how many segments we want of the snake. Before we do that, we actually add this game object, so that that initial block that I showed you earlier, which hosts this script, we add that block to the segments array, so that like brain block is part of the whole snake as well. So we want to make sure that that block is included in our scale transformations, else it will look like a kind of a worm with tiny little segments and then one big segment, or the reverse. So we want to say something like vector 3 new scale equals new vector 3. So I'm going to create a new vector 3 object, and then we want to put in here three floats that correspond to the scale that a user can put in. So let's just write scale. Oh no, autocorrect is tripping me up. So let's go and make that now before we forget. Anyway, I've just run into spread as well. Spread, as my comments deliciously explain, tells you how far apart the segments are. So that's going to have to change with the scale, else if we make the scale of each segment bigger, they're going to kind of overlap each other, which is something you might want to play with if you want like a non-segmented looking snake or something. But anyway, we want to have a scale, and we'll say by default it equals 1. But then when we go back to this function, grow tail, we also want to say that spread is affected by this scale. There we go. So if we halve the scale, we're going to times the spread by 0.5. If our scale is half, i.e. 0.5, spread will be reduced by half. So that will keep those things in scale with one another. The scale of each cube and the spread of the cubes from one another. So let's just write apply new scale to all segments. There we go. And adjust the spread of segments, just so we know what this bit of code is doing. So now we can write in here in our new vector 3 object scale. There we go. So we've got a vector 3 corresponding to the x dimension, y and z for our cubes. Have we applied that now? No, we haven't. We need to apply it to this game object. So we want to say this transform local scale, so we can actually change it, equals the new scale. There we go. So if it were, at the moment it's 1 by 1 by 1. If we set the spread to 0.5, this would now be 0.5 by 0.5 by 0.5. As simple and straightforward as that. We might do that now. So if I select my snake 4, which has the script that we're dealing with attached to it, we can see our new scale variable, and we can, let's make it 10 times as small. That would be really cute. There we go. I'll just save the scene. Go back to the code, because we've got to make sure, I've already done it here. We've got to make sure that we apply the new scale to each segment. There we go. That's all we have to do. We've already changed the spread. That's just one variable. Each segment will share that variable. There we go. That should be it. Oh, how long was that? 38. Oh, within a minute of 10 minutes. But I have no idea if it will work yet. Let's have a look. That would be good. That would be perhaps a first. Okay. It disappeared underground. I didn't see it, so I don't know whether it's... Oh, there he is! Just caught sight of him. Oh, he's lovely. Well done for watching and seeing the birth, witnessing the birth of our 0.1 sized or scaled snake. So if we release all these snakes, I won't have to jump down to the bottom because I think I've still got it bound to the key G. If I press G, I can release the snakes. Okay, they're big. What's gone wrong there? Oh, I know. I'm loading from prefabs. So I've got to make sure, let's just close this, that the prefab snake 4, which is in my assets folder, yes, I've got its scale at 1. So if I put that to 0.1 as well. When we release the snakes, they should all be baby snakes, which I think will be closer to what, at the beginning of this series of devlogs, that I kind of wanted. Yeah, oh, they look brilliant. I wanted to be able to see like loads of little snakes like this in a bound area. Talking of bound areas, if we want to make like a virtual aquarium, we can now kind of do it more realistically. I could have like a little aquarium for these guys. So we've got to think about maybe inbuilt to their movement algorithm, where they're choosing to change direction. Whether if they've gone over a certain limit, whether they want to turn back on themselves or loop around. Talking of which, I can make waypoints. So these baby snakes should come and snake their way to the waypoint. That looks really satisfying when they're baby snakes. And they're having no problem going through the actual waypoint, which reminds me of another kind of bug. In that the larger snakes, who are also attracted to the waypoint, depending on their change direction function, they can also go through their bodies when they change direction, when they're seeking a waypoint, which I've got to correct as well. What was I saying? They might never be able to get to the waypoint point because they might have to go, say, 7 steps forward, and then they can choose to go right, left, up, or down, or something like this. Or at the moment, they can go back for their body. So they might not have kind of the resolution of steps and change directions to go and hit the waypoint. So what I need to do is have more variety in how many steps they're taking in order to seek the waypoint. Or simply be a bit more sophisticated. So I could say, if you are in line with the waypoint, then, I don't know, turn more directly towards it. But there we go. Come over here, little snakes. There they go. Oh, very good. There we go. Okay, thank you very much for watching. That's how we can manipulate the scale of objects in our snakes.